So, yesterday's video was a topic about humans' effects on water, and today's topic is about volcanoes' influence on water and how our cycles have come to be where we go from a wet environment to quite a dry one. Now, obviously, volcanoes do it on a much grander scale than humans ever would, so you know. So, when I look at a volcano, I think of yes, its power, it's very beautiful actually, to be fair. So when we're looking at its influences on water, we have to take into consideration that in the beginning, Earth was a water world. So before there were any land masses, Earth was a water world. And then slowly but surely, you have your volcanoes rise from the oceans. And when they first start spilling their lava to create the land, they first interact with the ocean. And the first things they do when they interact with the ocean is cause this evaporation process to happen very, 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 very quickly. Now, if you know anything about salt water, you can actually extract fresh water from it, although you do need a lot of heat to do it. So in order to generate this heat, volcanoes are the perfect basically tweak in the system that allows this. Now, that's not the problem. So obviously before, when volcanoes first erupted out of the ocean, they spilled onto the oceans. They heat the salt water up at such a ferocious rate. They create this steam, and the water, the fresh water, then, because the salt water has boiled quite a bit, it does several things. So firstly, it ups the salt levels in the ocean because you're boiling it at such a rate. So like if you were to take a jar and put some salt into it, dissolve the salt into the water, it becomes salty water. If you carry on boiling this at high temperatures, you can start to extract again the fresh water in the vapor, and you're left with salt crystals. So in a sense, when you remove, so if you take some salt water, put it into a container, heat it up quite a lot, you are able to evaporate the fresh water from it, as in vapor, and you're left with these salt crystals. Now, if you were to do this in the ocean, you make the ocean a lot more saltier, constantly burning off this moisture or fresh water from the salt water ups the salt levels in the ocean, so the oceans get a lot saltier. Number two, this new thing called land that you've now created, because you're a volcano, you keep pumping out lava, and slowly but surely you start to create a landmass. This then makes the environment of Earth much more wetter, moister. So this massive steam goes out into the atmosphere from the volcano's reaction to the salt water, and what we then get is it condenses clouds, and then it starts to rain back down on the land masses. And this process goes on and on and on and on. So the more volcanoes there are, now you've got to think about it like this. I like continental drift, it's great, but Britain has a volcano. Every single landmass we seem to see always is associated with a volcano. So the more volcanoes that were active back in the day, many years back in our history, Earth's history, let's say, you then have lots and lots and lots and lots of this steaming sea that's creating a wetter environment. Now, slowly but surely as time goes on, the land masses increase and increase, and the volcanoes here, and in the beginning it just first erupted out, come out of the oceans, let's say, and it then started to react with the sea, but slowly but surely the landmass moved the volcano center point away from the oceans. And this interaction with the ocean slowly but surely started to fizzle out. So I believe there's one in Hawaii that's constantly reacting with the ocean, and it's constantly releasing steam into the environment. But as you know, as history tells us, that volcanoes become not as potent as they used to be. So we've got one here in the UK, Arthur's Seat. So it's no longer active, it's extinct. But now think about that. There's one that's extinct, then there's another that's extinct, then there's another that becomes extinct. And the land mass has become quite widespread. So let's say Arthur Seat, for example, created the UK. Let's imagine that now that it's no longer active. So there's no longer this interaction with the ocean. Thus far, it's not releasing as much steam into the environment, and slowly but surely the environment will also become drier, more arid. Well, how is that? Well, because the volcano's lava flow is no longer interacting with the sea. The sea is no longer being evaporated, and it's no longer condensing into the environment, and it's no longer raining back down. So what we have is this runaway effect. Like I said in my last video, there was so many factors that played into why Earth is becoming drier. You can take sinkholes, for example. You can take humans with this oil slicking. And there's another one, which is volcanoes that are no longer interacting with the sea. And the fourth one would be, it just went out of my head. It will be back for sure. So the next one is global warming. There it is. So when you start to look at how many problems are essential problems are being created, it's very hard to pinpoint why we are experiencing this environmental catastrophe, let's say, that we are all facing. Drier, more extreme weather systems. So it's very hard to pinpoint it. So like I said, I had to break it down and look at how many influences, how many factors are influencing this. And it wasn't until I started to break it apart that it then started to fit. So it's like everybody's got all of these pieces of the puzzle. One person says it's global warming because of pollution. One person says it's this. One person says it's that. Anyway, so what you all are doing is essentially holding on to pieces of a puzzle. And you are seeing a picture, but only a snapshot of a picture. The bigger picture is when you start to lock in and lock together all of the pieces of the puzzle. So I kind of was looking at different things. So volcanoes, I don't think I've ever heard of this. Like I say, I don't have this encyclopedia book, or I'm not following anybody to get this information. It's just when you take a step back, because sometimes great artists will create a picture for you, and up close, it's kind of a bit blurred, it's a bit hard to make out what's going on. But when you take a step back, the masterpiece becomes very clear, and it becomes extremely clear to see it. Now, breaking it down into bite-sized chunks is another thing. So we'll take global warming. Yeah, look at that from a distance. Okay, right, there's one piece. Okay, now let's take this oily substance that's forming across oceans. Okay, put that there. Yes. Okay, now I'm starting to see it. Yeah, that locks in with this. Okay, now what else have we got? Volcanoes. Oh, let's put that there. And then slowly but surely what you get is, how do volcanoes interact with this? How do volcanoes make the environment drier? Well, it could be because they release pollution. Interesting. They also no longer interact with the ocean. They've made so much of this spewing out their lovely crusty rocks, let's say, to make the land mass that we all walk on and take quite for granted. It's no longer reacting with the ocean. When with this no longer reacting with the oceans, it's no longer causing steam. So no steam also adds to a drier environment. So you've got two factors in one. So you've got pollution, which they do leak out quite a bit of pollution. And we now have the lack of interaction with water. Interesting. Lack of water, drier environment, extreme weather. So, wow, there's so much going on here. What about the oil slicking? Well, yeah, there's another factor as well. Piece that puzzle in. And then slowly but surely it all starts to make sense. Well, it does to me, most certainly, but I don't have this book of knowledge or people to rely on for this. I just have to think about it, and then off you go. So my way of finding this, I found it accidentally actually, was making something which we'll talk about in a minute, which was a way of extracting water. Now we'll take a look at this a little bit more detail in a minute once I flip the camera around. But just by looking at this, it was to pump in salt water into this one. It drops in the bottom here, and using the volcano to heat a makeshift element, it would then evaporate this, causing it to steam. It would condense in the top here and then drop down in this top compartment as fresh water. Then it would discharge into the next one, and the same process would happen again and again and again. And end result is fresh water. Now when I was looking at that, and I was sitting here thinking, trying to create this to try and make more fresh water from salt water. Why would you want to do that? Well, all the land masses, so if you take Australia, you take the Africa, you take any of the, I don't know, continents if you like, and you were to look at them, you can say that they're surrounded. Britain, we're surrounded by ocean water, but not much fresh water. So I was trying to figure out how we can make more fresh water, thus for great for farming. It's great for getting people out of poverty, because water is really, really good for us, so we need it. So it has lots of benefits to it. So I was trying to look of a way to find that, and that's what got me looking at it. And I was sitting there thinking about the volcano, and I really thought about it for a second and thought, hang on a minute, all I'm doing is a natural process that was done in the beginning. Earth's climate was much, much, much more wetter. So with that in mind, that's what then led me to this, eureka, ooh, excellent. So we look at volcanoes and we think, oh, pollution, pollution, pollution. I look at volcanoes and think, ooh, potential. Most people will look at them and think, ooh, good pictures, for sure. I see so much potential with volcanoes. Number one, we can make water from it. Number two, we can melt metals, get them thin enough so that we just need to use a minimal amount of electricity to cut it into shape and go and build something with it, whatever that may be. So, you know, you can also cook over them. So imagine a massive vat of food just cooking away under a volcano, cooked by a volcano, blanch a load of food up. It's got so many potentials, and you're not using fossil fuels and creating more pollution. You're just going with what's naturally occurring anyway. So seeing most of these lava pits, I like to call them, they don't actually flow, they just sit there, and it's just where the, I think, convection in rock form is happening. So the more hotter rock is coming up, cooling and then falling down, and then cooling and falling, and I think it's just this never-ending cycle that's going on there. So why don't we just go with the flow? Lava flow, whatever flow you want to take about it. So, or take away from that. So we could put tombs over this, and let's make some quartz from it. Let's melt metal over it, you know, and then we can start manufacturing stuff from it. So anyway, mainly it was fresh water. So in the beginning, I made these things called solar chasers, I believe is what they're called. Bear with me and I'll grab one. So solar chasers in the beginning. These have got some weird and wonderful names. Now, in the beginning, it was to have these either done by magnifying glasses, which is another video for another day, to heat the element, evaporate the salt water as these sit out on the ocean, and then they'd extract this, and basically, this one after I checked the final edit, I noticed that there were a few things that were wrong here, so I crossed it out, but never mind that. These are all on my website completed. And this one I called Africa. In no relation to it, I was just running out of names to call different devices, because, you know, 001698 starts to get a little bit tedious. I kind of don't like the numbers. I want to call them continents. Another one I got is called Britannic. Keep going, keep going, keep going. And so I started using names of countries to name different devices. So Solar Chaser, and then Solar Chaser, and this system would I named Africa. I just think it's such a beautiful sounding word, isn't it? Africa. It's great. So anyway, and either you would use solar panels, or you would use magnifying glasses to heat the element, heat the salt water, catch the steam once it condenses down, Then take the fresh water and then put it into a massive container or storage facility. And I was thinking about it, and I was thinking, the magnifying glass idea would work, but it works better closer to the equator. And this one where I was going to do it over the oceans of the UK, which is what I drew. It was, I can't remember the name of it now. Power Halo, that's the one. And that if we were to have these wind turbines fixed or floating, whichever, both ideas are great, interlocked with some solar panels out there, and you would be able to use some of these and designate some of these for making water from the salt water. And then that's what led me on to this one. So as I said, we will go on to most of these in more detail in just a bit. I'll flip the camera around like I do and narrate it as I go. So yeah, and that's then what led me on to volcanoes and how they really did in the beginning, when they was much smaller and they didn't create much land mass, how much of a wetter environment they created for us. Now, I like Earth because everything is in cycles. Everything cycles. Even the universe cycles. Everything cycles, recycles, cycles, recycles. So weather cycles. So we've got a lot of these cycles going off. Plants, when they grow, nice leaves, foliage, flowers, plants, and then when it dies and you can put it in a compost heap, it turns back to soil. I just find all of this cycling absolutely fascinating. So yeah, it always leads to cycles. So yes, when Earth has a lot of water, so who knows, maybe this process happens. Not 100% sure here, thinking out the box a little bit. So let's say the ice caps melt, top and bottom, and it completely melts. Oceans start to rise up. When the oceans rise, it then allows these volcanoes to be more surrounded with salt water. So the oceans, the polar caps melt, ice caps melt, causes the sea levels to rise. This rising sea levels brings, because most of these volcanoes are peaks, like mountain peaks, so the water level gets to about here, and the next time the volcano erupts, it then creates steam once again. The more steam, the more steam, the more steam, the more steam, the more wetter the environment. Thus it creates this more of a freezing effect back at the poles again. So then the ice mass starts to expand over North and South Pole, and then once it does that, it grows the ice sheets. Thus the water of the oceans then recedes once again, and then maybe they melt again because the drying out effect happens, and it rises up again, and the volcanoes spill out again, as they do naturally, and then it causes the environment to become wet. It's more wetter, it gets more colder because it's damp, less frequent storms, and then the oceans recede once again due to the freezing over here, and then it melts and freezes, melts and freezes, and it's all due to this process of drying out, and another process of once it's dried out, the polar caps then melt, ice caps melt because of this drying environment. They then melt, it causes flooding. Once it's caused flooding, it then interacts with the volcanoes once again, makes the environment damper environment, then it causes the ice caps to melt once again and freeze. Back and forth in this never-ending cycle. But it's just because humanity haven't been around for long enough that we wouldn't know whether that's actually going on or not. So we can look at different areas and find shells and sea life in weird places, in tops of mountains and mountain peaks and stuff. So could this be because two, I forget what they're called, tectonic plates, smash into each other and cause a massive mountain, or do they go down and cause a dip and the ocean comes crashing in? Maybe that's happening too. But also, this process could be happening as well. So this one seems more feasible for me because it seems to tick all the boxes. Much more flooding, salt water, whoosh, washes in. The volcanoes then start reacting with this salt water when they erupt. And just for as long as the ice caps are about and there's a lot of land mass, the same amount of time will happen when it floods. And the volcanoes then have to slowly but surely start interacting with the salt water again for it to start receding, because it then creates a damper environment. You remove most of this moisture, put it into the air, blah blah blah, XYZ. So the only way you would really know whether this works or not is an experiment, I suppose, that could be done, but who knows how it would end. Is if we started dampening down the environment in certain places, so like pouring fresh water on the hottest days over places like I don't know, I think there was a process called water butting, where you fill a water butt with water and then let it evaporate and calculate how long it takes to evaporate the water. So I suppose if China was to have these massive trays of water, lots of it, on their hottest days, and this would then, the sunlight would hit it, it would cause this water to evaporate, no oil slick. And as this evaporates, it should lower the storms for America in a season. You should notice a difference. It's a colossal experiment, to be fair, but what it should do is stop most of these tornadoes, hurricanes, from forming out into the ocean and moving across towards America. So there is one crazy way of doing it. That's extreme. So I don't know whether you can get this experiment done in a lab somewhere. It just seems quite challenging. I'm not going to say it's impossible, but most things are possible, and humans have a canny knack of figuring things out and making things happen. So it's a possibility, but it's one that's worth looking into. So yeah, so with yesterday's video, and this is just basically a quick follow-up. I say quick, 22 minutes, and I've already spoke for England. Yep. So I just wonder if it's this cycling that keeps happening. The ice caps melt, flood the land, volcanoes then start interacting slowly but surely with the salt water, causes it to evaporate, then it extracts the fresh water from this, salts up the seas a bit more, then it recedes because the ice caps then melt, refreeze again because the environment becomes damper, in a process that takes just as long one way, where we can walk across the land and the oceans are really far away from the volcanoes, and perhaps the process takes just as long when it all floods and the volcanoes then start once again reacting with the oceans. Ooh, that's a new thought, by the way, that come from making this video and it just burst into my head. So brain cells are definitely tingling today. So that's caught me off guard. So that's a new level of thinking. So I don't know, maybe it is, maybe it's not. So anyway, I think I've covered enough on this subject for now. Oh, I've really got to go and recheck a load of stuff that I've written. Usually I'll write this stuff that starts entering my head, so I will be going off to do that. So I'm going to finish this video off so that I can go and jot that down into some writing and just see where that leads me. So it's plausible, it explains why we have so much sea life in strange places, and it's also a cycle. I don't know. So anyway, but get into this. This is what led me to making more steam or creating more fresh water. The more fresh water we have, the more it's going to evaporate. The more it evaporates, the more we as humans would then be able to fill the rivers with this fresher water that we make by wasting it to the rivers. So another one I was thinking about yesterday was, how can we get around this without digging up the roads? And you know, we have wastewater from your toilet should go to these treatment centers, but the stuff that you put down your sink, and if you're able to clean it using one of the devices mentioned yesterday, Eco Drier Part 2 I believe that is, yeah, if some of these drainage that we have in the streets go to the rivers, so your drains that we have that take the water off of the roads, if we were to somehow connect these purer form of water to the drains, would this not put it into the rivers, thus for causing the rivers to be slightly more and allowing the sunlight in places to start evaporating this water faster? Thus for, would it not start controlling or stabilizing the ice caps a little bit more? So who knows? Who knows? So it might be a way to do it. And I'm not talking about after you've used your dishwasher or your washing machine, that dirty water goes straight into the drains. Definitely not. That's bad. What we want to do is extract the moisture, which I've already done this experiment within one of the devices I've already built here, and it's up and running. It does a lot of stuff for me. So if you were to take some dirty water that you've take your washing machine pipe, for example, and put it in to a container, and your wastewater then fills the container up. You then take this wastewater, which is visibly dirty, very yucky, and you put it into the eco dryer. What it does is it extracts the moisture from it, and you get clear water build up in the system. And slowly but surely it evaporates from the container, and what you're left with is this dirty sludge. Like, I don't know, it's almost like sometimes it works two ways. Number one, if there's a high amount of oils in the clothes, it leaves this oily, dirty sludge. Or if there's less oil in the clothes, what it leaves is like a powdery dirt residue that you can just sweep out or hoover up or go knock it outside and just, I don't know. And it's very strange, isn't it? Or you could put it in your wheelie bin or whatever, just like a hoover. After you've done a hoover, you've hoovered round and you collect all up inside your bagless device, let's say. You disconnect your hoover and you go and empty it into your bin. It's kind of stuff like that. It's what it looks like. It's the only way I can explain it away, to be fair. And the result from the water that you get from it is clear. Just like tap water, it's clear as that. It doesn't smell of any chemical. I've never tasted it and I won't. It needs testing, is what it needs. So I'm at this level right now where I can't test that myself. Well, I'm going to give it a good go, but I will test it out just to see how pure it is, because it would answer a lot of questions, and then test that leftover either sludge or dirt layer to find out what is exactly in it, and should it be thrown in a bin? Does it go to landfill where it never interacts with water again? You know, and then this purer water, if it does check out to be pure and it is good, this is the stuff I'm on about, that then should go into your drains outside, and then should be safe enough to go into the rivers and not kill the fish, and in fact probably boost their life as well, to be fair, because it's just pure water. So that's something else I wanted to cover on. So right, as I say, I'm going to flip the camera around and go through some different drawings, but definitely this volcano one is sticking in my head now. Ice caps melt, floods the land floods, volcanoes then start reacting with the oceans again, the climate becomes wetter, it then moves away via the climate steaming it all out. Then we have more water, fresh water, than we do salt water. The seas get slightly more saltier. This then causes a damper environment. Damper environment then allows the ice caps to freeze once again. Water recedes, more freezes. Once it's frozen, it then, the same thing, slowly but surely it starts to dry out. It becomes too dry, and then it starts to melt the ice caps again, and then it causes the flooding. Then the volcanoes interact with the salt water again, and thus for this cycle keeps going over and over again. That's how it's sitting in my head right now. So, interesting. It's weird doing videos, to be fair, because it really, this is more my benefit, I think, because it really pulls on my thinking, which is great. So yeah, I'm going to leave this here, and then we're going to go off to some volcanoes as to what led me to this and how we could use volcanoes to our advantage, and perhaps, maybe, stop this process that's going on, this cycling, and become in control of that, because mass floods is not good for humanity, especially when there's so many of us on this planet right now. So sometimes we have to do things that, I don't know, they'll say, oh, we're never going to control this or we're going to do that, but sometimes we may need to. There's going to be a time in our lives where we're going to have to say, we're going to have to call that card. So it's best to think about it and have all of this knowledge and understanding right there, so if it does start happening, we can do something about it. very fast, very quickly, and start to reverse these effects. So, and again, if the volcanoes are reacting and creating pollution in the atmosphere, let's say, and it becomes more damper, it should be able to grab these particles, rain it back into the ground, cycling again, and causes more carbon and different types of nutrients from the volcano that then spreads it across the whole of the globe, which is great for forests, trees, and it feeds them. So yeah, right, that's it, that's me done. I'm going to flip the camera and then we'll go on to another one. So yeah, see you in a bit. So as I flip my camera around and explaining about how volcanoes can be used to our advantage, let's say. So here we have a drawing done of salt water comes in, fills in this one, and the volcanoes, I don't think you'd see lava, but still, I was talking about that magma pit, or the heated pits of just, they're very, 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 very hot if you look at the volcanoes from a thermal perspective, and using these thermal parts to do this, and many other things too. So here we have a pump that pumps up salt water, lots of salt water, pumps it into here, and as this heats these elements or rods in our system, it causes this salt water to evaporate, and as it condenses and the droplets form up here, they will then put purer water, which is fresh water versus salt water, fresh water I should say, and then a little motor up here pulls on this and that fresh water discharges into the next one, and the same process happens, and it fills in this one and then discharges into this one, gets heated from here again and then evaporates, and slowly but surely as this keeps running in and in and in, what the end product is that you should get is fresh water out. Thus far we can drink with it, we can put it on our crops, grow lots of food. So this is one scenario that we could use for volcanoes, and even if we was to let this interact with sunlight, it would steam and it would cause us to have a wetter environment, let's say. So lots of uses that we can do, but they have to run into each other. By the way, I'm obsessed with triangles, such as triangular shaped, they do look at from a perspective. Volcanoes look triangle, and they're also this granite type material. It's just kind of a red hue. I like it. So this is one particular system that we could do, and we would extract fresh water from it. So like I said, that the ice caps may melt, fill up to this area. This then starts to create the steam, and then might allow the ice caps to then refreeze in this constant cycling of freezing and evaporating, melting and flooding, and then refreezing, and so on, and just in a repeated fashion. But anyway, so volcanoes could be used to our advantage. Here's another one. Never mind the drawings, this looks a bit like a frog to me, but there we go. Now what we have here is a pulley system either side here. Now if this moves slightly over here, it will cause this to have tension, so it will lift it up and make it higher, and it will drop down. And this is what I called either a tomb or a chamber, and it's triangular shape, and there's a good reason for it. So the heat from the thermal imaging, when you see it over the volcano, you see these massive pits, lava pits that are very, very hot, and they're massive, absolutely huge. But if we was able to get a pulley system that was able to cope with extreme temperature, and a triangular like bell or dome or tomb, and we were to fill this with shards of metal, we would then be able to melt them inside here and knock them out once we're finished. Once it's all melted and we've let it cool down a bit, we could then knock these out of the bottom of here in a process that allows us to melt metal, the water one that we just saw. It also allows us to do all sorts of stuff. Now, quartz we could do in here for solar panels, metal to build wind turbines, make motors, you name it, it can all be done here. Like I keep saying, go with the flow. Go with the lava flow. It's already there, it's already hot. You don't need fossil fuel. It's already here, natural. So, moving on from that one, and what we have here if I can get this to go in the camera's view better. There we go. So we have a thin slab of metal down here, really thin. And then we have a slightly thicker piece and an even thicker piece. So if we was to put inside these tombs quartz, grind up some quartz and put it in there, I'm pretty sure the temperatures are there that were needed to cook it. And it's also for fragments of different metals. Even if you were to put all types of different metal in there, it would all uniform. So if you had iron here, you might get a bit of steel here, and because they've all got different melting points. So just like the great iron catastrophe that happened in the planet, the same thing could happen inside these tombs, is what we're after. And then what this does is it makes it so this one, if it was for like can size or tins, different things like that, it's very thin and flimsy. But we could use this, and we don't need any fossil fuel to achieve it. This one's slightly thicker. Could be like your rods that you use in building work for making steel frames or cages to add to concrete structures, let's say. And this one could be here. Now, these slabs are going to be huge, massive, but when we take a grinder to cut away the metal, different bits, what we need, cut it into shape, if we take that in terms of electricity or energy or fossil fuels, it's far less energy to cut this off into shapes that we need and into sizes that we need. The most majority of the energy is used in getting it melted in the first place. So it would be brilliant. We would no longer need to rely on fossil fuels. We just use the natural burning of volcanoes and the natural heat that's coming out of there to create this. And here's one that's slightly more thicker. Now, if you had different metals at different shapes, they will always keep as this slab effect. This bottom part of the tomb drops down so that then you can just push out this slab and it goes on a conveyor belt or wherever you need to take it. And yes, everyone will say, oh, this is quite dangerous. Oh my God, what happens if it erupts? Well, you wouldn't go there. You would send your machinery to go there. Once you've built the initial thing. See, piling work, a foundation work where you would drill in some piles into the side here. I was thinking of maybe building a factory on the side here. Not really sure. If the volcano erupted, probably going to do some damage, but I'm not sure whether we could build something here that would withstand it and purify the air so that if the worst were to happen, anybody inside here would be safe until it all cooled down and died down. So yeah, or better still, we use robotics inside here so that this will move over here, drop out its slab, more then goes into it probably from the other side and refill, and you would have more than just one of these on here, and they would just hook onto it and just move into position. When one moves away, needs to cool down, another one moves in position, ready and waiting, and starts bubbling away and creates its slabs. And these different slabs would then, getting it from here to here is quite easy. It's downhill, so it would fall quite well, and we could get different types of conveyor belts nonetheless. So here it hooks over the zip line, if you like, type material, and on the pulley system, so it's got two little knockers so that it can be moved one way or the other, and then we can knock these out of here. And you might say, well, wouldn't these melt? Well, no, because we would make these in a way that these would not melt. They have a very high burning or melting point, and all the metals that you put in there would melt at a much lower temperature than the outer casing. And what this does is it gets rid of this mass amounts of coal that we need to burn in order to get this into this shape, and then we just need to use a small amounts of energy just to cut it, which is far more easier than melting it. So, I kind of ran away with this one. It's led me on to some more, but that's going to be on another video. But for now, this is basically what I've got. And then I went a little bit more further with it. Now, this one again is thinking out of the box. This is where I have my little wacky moment. Is where here we have steel and iron. And I just wonder if the volcano's heat would cause an electrical charge. Because I don't know how great it is or how much of an electrical charge happens when you melt steel, but I know it starts sparking. Different types of metal, when you get it hot, it really starts sparking, and zapping everywhere. And I just wonder how much energy that is creating. I will look this up at a later date. And if it's significant, is there no way that we can generate large amounts of power from the heat melting the stuff inside the tomb and it causing this sparking? Is there some way that we can extract the charge from it? And if so, how much charge? Is it worth it? Could it create some energy to power different things at the side of the... So like to power the zip line in the first place, this pulley system would be a giant motor. Obviously it would tension, more tension, it lifts it up higher depending on what type of material you want melted. The temperature could be controlled by how much slack you give the line. So if it's more slacker, it gets more closer. If there's more tension, it comes up a bit more and thus more moves it away from the heat, so that you've got a gentle heat, and that's how you control the heat. Now with the one with making the energy, if it's even possible, would there not be another one slightly behind this one which then would power this, so we wouldn't need to lug power cables up there? Now I know some people would say, well, wouldn't this get destroyed basically inside the eruption, or would something erupt? When it erupts, wouldn't all of... Yes, it definitely would get destroyed in an eruption, but just like we do when we have tornadoes, hurricanes, or anything else on that matter, you rebuild. So if we made this as cheap as possible, either make it so that it can withstand these influences that the volcano may have on them, and extreme heat, and it can withstand all of those different types of elements that are going to be thrown at it in the event of an eruption, yeah, sure, these might get destroyed. But once that rock layer after an eruption has set, we can then just put these back in again. These are not very expensive to do. So yes, we can, and if we have size monitors on here, we'd be able to at least give ourselves a little bit of a warning as to when it's going to happen, and maybe, possibly, have some sort of quick disassemble, or who knows. So yeah, they could get destroyed. So if we made it as cheap as possible and easy build, I think that shouldn't be a factor in here. So perhaps this building might get destroyed in the process, or we learn how to build things that can withstand these types of heat, this type of heat, this type of shaking that goes on, and slowly but surely we'll build up our knowledge and understanding of how to make things more, I don't know what the great word would be for this, but just to make things more stronger and more resilient to withstand these stresses. And I think that's good for knowledge, especially on the planet and out in space. If we were to ever witness anything of extreme heat, we would be able to build more and more reliable probes that could venture into different planets, different stars, stuff like that. So we would be able to make things that could withstand a little bit more. And slowly but surely, just like mobile phone technology, we can run away with this. So yes, it can get destroyed. It is a possibility, but let's not overlook the fact that the benefits of this definitely do generate and outweigh any risk that's associated with it. So yeah, so that is where I'm going to leave it for today, I think. So yeah, we've got the thinning cans, we've got the different levels of metals, different thicknesses, how we can get it out. So covered that. The electricity one, again, just thinking out the box, this one. And then we have the building and how we could use this to our advantage to melt stuff. And then finally, the one that we was talking about in the beginning is water. And we can convert salt water very easily from one form and make it into fresh water toward the end. And I think that's beneficial for all life on the planet, to be fair. So a lot of things start to sew together. And this video is just merely an updated version of yesterday's one, and it just helps you understand a little bit more. There's been quite a few revelations in this one, let's be honest. For me, most certainly, the flooding and the melting of the ice caps. That one I'm definitely going to go and work on. So yeah, as of that, that's another video down. Doo-douche, all out in the box. So yeah, whatever you're doing, I hope you have a fantastic day, fantastic night, depending on where you are in the world. And yeah, thanks for tuning in. See you next time.